So today I'm going to talk about the application of Benford's law uh, with respect to US election 2020. So you can download the data from kaggle.com, and they have the US election data. And what I've done is I just downloaded the president county candidate data. So once you click on here, you can click on download, and then we just need to open it. Once this is opened, okay, so it shows state, county, candidate, party, and votes. So what we are going to do is to create a separate worksheet. Let's call it state. Okay, state. So in this state, so I'm going to copy this and put it right here. And I'm going to remove the duplicates. So remove duplicates. And the data does have headers. And we can sort this as well. So we have the state information, and I can also have the candidates. So candidates, basically, we could essentially do this. Actually, just copy and paste right here. Suppose we just want to explore two candidates. Okay, two candidates. Okay, so now let's. So the Benford's law look at the first digit of the votes, the count of frequencies, and by Benford's law, it has this digit. You have a 1 through 9 as the first digit. And by Benford's law, the distribution should be, sorry. So the distribution should be following the log distribution, okay, equal to, let's say, log 10 over 1 plus 1 over d. This is a digit, okay, 1 over d, okay. So the first digit is supposed to be 30% in this case, okay, and it will decline. So essentially, if we have a plot, it's going to be something like this. Okay, so let's delete this one, or we could let's just delete this one, and this is a Benford's law. Okay. Let's make it a line here, solid line, a solid line here. So this is the Benford's law, distribution. And in this exercise, we are going to look at the president, current president Donald Trump versus the president-elect Joe Biden, to see if their votes distribution is similar to or conform to the Benford's law. So let's get started here. So we need to get the first digit. So here we'll split into columns. So let's keep these votes here and create a separate one, and then we'll split it. So fixed width, next, 1, 2, 3, 4, 5, 6, 7, 8. I don't think you get over 1,000,000,000 votes, so just click next and finish. So now the votes are the first digit is separated from the rest, and we need to just count the frequency of this first digit. So the way I'm going to do this is, so I'm going to have let's say the candidate name here. So let me just insert a row here. So let's put a candidate name here. So let's do a list. So do a list. So go to data and data validation. You allow a list. Okay, and the list will be from this two. Okay, this two. Just click on OK. So now we can have this selection here, and of course we can just extend this selection, so we can select different ones here. And I also want to have stated. So similarly, I click on Data tab, and on the Data ribbon, I do the data validation and allow a list. And this list will be the states. So basically, the 52 states here. Okay. Click on OK. So now when we have the state information, so we can select, say, for example, just for Michigan, for example. So let's say Michigan right here, or Illinois, or any. Okay. So now I'm going to count. Okay. So the count is just simply count ifs. So count ifs. The first criteria is this column, this candidate column. We want to have an absolute reference here. Always refer to this, and this should be equal to, let's say, Joe Biden. Okay, Joe Biden. Okay, and then I want this. I want to count this first digit. That's first digit. Okay. So let's say. So this is a first digit column. So this first digit I want to be, let's say, 1. Okay. So in this case, 1. Okay. So I just use the countifs equation. So let's say equal formula text. Or let's just do a formula text here. Okay. So that's a formula we have so far. Okay. And of course, I'm not quite satisfied with this one. I want to use Joe Biden from the cell here. And I want to always refer to this row 2. So put a mixed cell reference there. And this one, I want to always refer to this column. So A, column A. So now I can just drag it downward here. And because of the cell reference we used, we can easily drag it over this side. Okay. And here, in addition to the criteria of digit and candidate, I also want to add another criteria, which is the state information. So I want to have this state information. Okay, state. So always refer to this E1, okay, state information, and the criteria range would be from the first from this worksheet, and because it's in column A, so I just change this to column A. Okay, so this is column A. Okay. So now I will have this number of observations for this one. Okay. So let's maybe Michigan doesn't have uh, a lot of observations. So maybe let's choose a Illinois. So one of the keys here is to have as many observations as possible. So if you don't have enough number of observations, then it could be potentially misleading. Okay? And here you see we have a lot of observations. So the data will be okay. So we have the numbers, and we need to do a count. So we need to basically to divide by the sum of this to get the proportions. Okay, to get the proportions. So we could just copy this and put it right here, and here we just need to use this one divide by the sum. Okay, divide by the sum of this. Okay, sum of these numbers. And we do want to have an absolute cell reference function f4. So here I do want the column to change when I drag. So just need to get rid of this dollar signs there and enter. So that's the proportions. So we have the proportions, and here we can drag it this way. And once we have the proportions, so we can add these proportions to this chart. Okay, to this chart. And the way we do this is we are going to just select this and home copy, and then we click on the chart. We can just paste it right there. Just paste as new data series, and then click on the chart. We can do chart design and have a chart type, have a combo chart type, and click on OK. And we want to have chart type Benford. Let's do a line. Okay, and this let's do a column chart, and here let's do a line chart. Okay, and a number of cosmetics. Okay, a number of cosmetics. So one cosmetic I'll do is just change this to black color. And another for Joe Biden is blue. For Donald Trump is red. Okay, so it's red. So here, if you want to add axis, so it's proportions. Okay. So leading digit, and here is a proportion. Okay. So why we got this disappeared? So we need to have a axis, title, vertical, proportion. Okay. And here the vertical, the horizontal axis is a leading digit. Leading digit. Okay, so here we go, and we can make it black. Okay, make it black, and maybe increase a little bit. And now we can click on this chart and make this chart a little bigger, and move it down a little bit, just a little notch. Okay. Okay. So now we have this beautiful chart. This is we can add a title to it too. So the title would be horizontal. Just do a title, okay, above the chart. So it will be Benford's law and U.S. 2020 election. So let's just do 2020 election. Okay. Okay. So we can see that this pretty much conforms to the both candidates. The proportions conform to the Benford's law, and you can apparently very look at experiment with the data to see if the state data also conform to the Benford's law. Let's just make a copy of this for example, just make a copy of this, and then we can change this to, for example, this column. So the way we do this is, let's just go up under a little bit. Okay. So the way we are going to do this is just click on here and copy and just paste on here, paste on this chart. Okay. So just paste. So this is another one, and you see this even in Michigan for Joe Biden is it's conforming to the Benford law. But if you cherry pick different states, you may have different data. Like online, you have it from the Reddit and other websites claiming that there's a voter fraud, and you could potentially make a case there, but it really depends on your data quality. But for the big data, like for all over the country, then clearly we see that the election data conforms to the Benford law, and for specifics, so we need to look at the data further. And thank you for watching this video.